Hello everyone. Today I'm going to give you an overview of the recent published archive paper, GLaM, Efficient Scaling of Language Models with Mixture of Expert. For those of you who are not familiar with the Mixture of Expert or the switch transformer, you can check my YouTube channel. I have a short tutorial or overview about that one. And it's interesting paper to read because I draw a conclusion from what I see in this paper. It means supposed to use the GLaM model in your AI bot. It can easily cost you $90,000 per hour, which is probably more expensive than Cristiano Ronaldo. Or I think CR's salary is about 50K per week. I think he's a. I think he might. I don't know much more. I think he is the highest paid employee in the world. Okay, there's a lot of interesting thing mentioned that in this paper. Let me show you some highlights first. First of all, what does the GLaM mean? G means the general list. LA means LA plus model means LAM. It's a language model. It's a language model. And it's the first time the model parameter compared to the OpenGPT-3 or D5, whatever you call them, these models. This is the first model that exceeds 1 trillion parameters. This is significant gain. And this is 7 times larger than the GPT-3, as we know that GPT-3 is already very large. And they got way better results compared to GPT-3 in 29 NLP tasks. Okay, let's first see what the GLaM did. Yeah, just select the mixture of expert or switch transformer mentions. The GLaM model is a encoder or pre-trained model, I think. Table, right? I have a table showing the difference between different models. Yes, this one. Can you see table 2? Okay. As we all know, bird first. I have a tutorial or overview of bird. Search that. I don't have T5 at GPT. But bird is like a pre-trained model, right? Training model. And remember, pre-trained model, encoder, they're the same thing. Encoder, it's an encoder. And T5 means you just not only have the encoder, but you also have the decoder. You have lots of tasks. So GPT-3, same thing. GPT-3 is only decoder. You see here, it's only decoder. Switch transformer, it's encoder plus decoder. It has tasks. And GLaM, it's a MoE decoder only model. Okay. So how is it being trained? So let's see the figure 1. You can see those are the, let me see if I can write on this. You can see my cursor. These are the input word pieces. So you can see these are the common things that are being used in the transformer, right? Input, multi-head tension, add a norm. But this part is called a switched feed-forward neural networks, or switch. This is what the mixture of expert comes from. And the rest are the same. The rest are the same for the transformer. Get the encoder output. But I do have a question for the author. I think they might have typed something wrongly. Why this is a MoE decoder only? It seems to me this is an encoder. Maybe I'm wrong, but I only read the paper for less than 2 hours, so yeah. Yeah, what's different than the switch transformer is that in this work, instead of just using one expert at one time during training or inference, they use 2 experts. Why they use 2 experts? They didn't mention too much of the reason they did this. Only they say it could provide a combination of E squared experts' opinions. Well, this is known, yeah. But why 2? Why not 1 or 3? Didn't mention too much of that. But I guess it makes sense to me, you know. I like the 2 number. I mean, 1 expert might be small. These are the size of the model. You can see if you want to get a dense encoder model, you can go up to 137 billion parameters. But you can also get a mixture of expert model. So each expert has 64 billion parameters, and that there could be 64 experts. But you may ask, why the number of parameters is not 4 trillion parameters? Because 64 times 64 is 4 trillion, right? Why the 1.2 is less than 4 trillion? It's easy to understand, because the duplicated thing or the expert only happens here. You see the FFN part. All the add and norm, multi-head attention part, different experts are sharing the same networks or layers. So it's not going to be 64 times 64. But eventually they do get a parameter size of over 1 trillion. 1 trillion. And the price wise, I saw they use 1,000 TPU V4 chips. My estimate that each chip will cost you $1,000 to $10,000. So this machine will cost you about $1 million to $10 million. It's expensive. These are some ablation studies on model size and the scores, trade-offs. It's not very interested in those things. The interesting thing is that the 1 trillion model trained with less amount of tokens actually outperformed the GPT-3 model trained with more tokens with by a large margin. This is interesting. So which means that your training data or the data in your pre-training is less than the GPT-4, and then you got a much bigger model than the GPT-3. GPT-3, sorry, it's GPT-3, and your model performs better than the GPT-3. And they did some social studies, in my understanding, especially the core occurrence prompt. For example, what does this mean? This means that, so suppose I give you a term, say key, okay, key. What are the words that are usually coexist with this given term? For instance, he was very, what word? Smart? What if suppose you use the term she would be described as what? Pretty. This is how you see the words are being related. So you can see interesting. It's this one. You can see once you give the he prompts, you can see the most common descriptive words are here. Think why there's a word much over there. Didn't quite get it. But once you have the word she, and definitely the word pretty gets here. Beautiful, little. And there's some words that the he didn't get. Good. And I think this is interesting and important because remember that the GPT-3 is being used for natural language generation. Natural language generation, right? Especially you give a question, it generates an answer. This is natural language generation. And you want to make sure that the answer you generated are not biased. So this is the reason why these researchers are studying race, religion, gender, things. Very useful. And here, I think this is the part that intrigues me the most. They say the GPT-3 model will cost 1287 megawatts per hour. Suppose the server is in California. Okay, I just checked the PG&E. I think my rate is about 0.35 kilowatts per hour. And suppose I'm very rich. Suppose I'm very rich. I got a GPT-3 model. I want to use it to generate some answers. You ask me some questions. I use that model to generate answers. I got 1 million kilowatts, right? This equals to about $0.5 million per hour. So that means, so if I set up a server and I use that to answer your questions sent by people all over the world, I give the answer using the GPT-3 model. And then my machine's electricity bill would be $500,000 per hour. So that means every day, each day I have to spend, so it's gonna be $12 million per day. Every day I will pay $12 million electricity bill. And they say they managed to reduce the cost by 6 by using their GLaM model. Yeah, that makes sense. GLaM is a mixture of expert model. It's sparse, so it costs a less amount of computational power. But this is still $12 million per day, right? And I did some math. That will cost me about 90K per hour. I think this is probably most expensive bot you could ever have. Way much more expensive than. Yeah, I think this is a very good paper. The most important thing that I think this is interesting is that uh, the willingness of the researchers from Google to share their state of the art research results with us, people like us who does not have the capability of testing out super large model with such a great amount of budget, but we are able to at least get to know what's happening. This is why I like this work. Thanks, Tommy. Let me know if any questions.